Most of the world's organic waste is wet. Think food scraps, sewage, and factory byproducts. That kind of waste is tough to turn into energy because dyeing it takes a lot of time, money, and heat. Rhinoflux has found a way to skip that step altogether. It uses a liquid-based process to turn wet waste directly into clean electricity on site. Alex, what problem are you solving? Because most organic waste is wet, as I said, and traditional systems struggle with that. Why is it such a challenge?
We're solving the cost problem because the biomass contains a lot of moisture and the traditional methods such as combustion. But when you try to burn the wet biomass, it takes a lot of time, it consumes a lot of energy. So the actual energy that you can extract from the biomass is going to be very small and it's super expensive. So that's the problem that we're trying to solve.
How does Rhinoflux turn wet waste into power without dyeing or burning it?
Our solution is fundamentally different from the traditional methods. We're using the electrochemical process. So it's similar to the battery. So we use the special liquid to make chemical reactions and extract electricity without combustion.
You've compared your system to a battery. Can you explain that in simple terms?
Sure. So we are using the special liquid, and we make the chemical reaction to charge the liquid by biomass. And after that, we extract electricity, discharge, and get the electricity. So that's the battery charged by biomass. That's our technology.
Your process also produces something called biogenic CO2. What is that and why is it valuable?
CO2 is not valuable nowadays, but the biogenic CO2, which comes from biomass, is originally from the atmosphere. And the plant, when the plant photosynthesizes, it captures from the atmosphere. So the biogenic CO2 is not increasing the level of CO2 in the atmosphere, but it has the environmental value. So when you fix that, store that, or reuse that, then you can reduce the atmospheric CO2.
And unlike most systems, yours separates CO2 naturally inside the process. How does that happen without extra equipment?
Our liquid contains metal ion, and it's actually the carrier of oxygen. So when the liquid makes the chemical reaction, it carries the oxygen, the pure oxygen, and give the pure oxygen to the biomass. So it generates very pure CO2 without any impurity.
Can you give us a sense of scale from 1 ton of typical wet waste? How much electricity and CO2 do you produce?
Electricity, we can produce 2,000 kilowatt hour, and which is equivalent to 20 Tesla Model S. And then also from 1 ton of biomass, we can get 1.6 tons of CO2.
What kinds of waste can it handle right now, and what are the current limits?
We're trying to accept many kinds, but now we're focusing on the production residue from beverage and food factories. That's because it doesn't contain a lot of impurities, it occurs everywhere, and it contains a lot of moisture. So that's the perfect fit for our technologies.
If a site doesn't need CO2, say it's not a beverage plant, what happens to it? Can it still create value?
We're basically taking out and give it to our partners. For example, it can be utilized as a source of carbonated water, dried ice, or some partners are adding more value to make it to the chemical products.
You only founded Rhinoflux in 2024 and already have pilots with big industry names. Can you tell us who's involved?
The Coca-Cola and Veolia, which is one of the largest water treatment company, and some Japanese major food manufacturers.
How will customers actually use it? Is this a product they buy, lease, or operate as a service?
Basically, we provide the power plant and then they are operating the plant by themselves. That's because they have the existing operators and our power plant is not that complicated to operate.
And you're based in Japan. What are your plans outside of the country?
Biomass potential is enormous it can meet more than 70% of the global energy demand, but most of them are underutilized. But after Japan, we're targeting Europe and US. Europe and the United States have realized the value of biogenic CO2 already. So if we're able to sell both electricity and the biogenic CO2, then our business is going to be much more attractive to the customers.